Hey, are we live? Are we live? Alright, guys, for those of you who have been following me for a really long time now, you probably would have known that we usually stream games, but I do have a little bit of time off on my weekdays, in which I would like to. Alright, how do I start this? So for those of you who don't know, I do have more than one channel other than my gaming channel. On my YouTube channel, I have more than one YouTube channels. Another one is involving tech and IT basically. So if you head over there, you can see that I would I do well. You can go to the handle below. It's called Dead Bikecraft. That's my YouTube channel, and the Dead Bikecraft over here, that's my YouTube channel actually, for tech IT related stuff. So that's where I actually do a little bit of tech and IT stuff, and other than if you head over there, I do quite a bunch of hardware stuff, but other than that, actually I do a lot of on software as well, and in fact my day job is related to that. And yeah, so I was just thinking that because it has been close to 2 years, I believe, this year, so I'm just thinking that alright, let's start by doing this, so that we have more content to stream basically. But of course, I don't think I may stream my software development side or any IT side on the usual streaming timing, which is at night, SGT, because that's already that's already reserved for playing games. And as you guys know, a lot of you actually watch me playing games, right? Yeah, so this one is just another way for me to learn and also develop stuff whenever I want, because I just feel like when I do it on live, I'm more focused, and hopefully I can get things done better. At least that's what I've seen on my game stories progresses. We have completed a lot of our games, if you have been following me on gaming live streaming. So yeah, hopefully we can reproduce this result on this as well. So what am I doing right now? Because this is the first live stream for my tech channel, I figured that I'll just do something that is easier to do, which is learning. Yeah, I mean, if you guys don't know, other than watching other game streamers, I actually do watch a lot of like software developers, game developers streams as well. So hopefully it's not as bad. The one thing that's missing currently is music. We currently don't have any music, so yeah. And for those of you who have been following me on the gaming live stream, yeah, don't wish to have webcam over there, guys. I only have webcam here because we don't have music, so I just figured that if you are just watching my screen, it will be pretty boring. So yeah, at least we are at 150 subscribers for my gaming channel, but for my tech channel it's relatively new, even though it's each of the video has pretty high views, not gonna lie. It's pretty good to see. But yeah, I figured that I'll start doing live webcam streaming, so that I won't be so awkward whenever I go live with webcam next time. So yeah. Hey yo, Asakura. Dude, I didn't expect any of my game viewers to be here in the daytime. Hey, welcome. By the way, I'm switching up a little bit on my display here for my text streaming. So yeah, I'm still checking a little bit of stuff. So again, guys, if you guys have any, like, free music that I can stream online without getting copyrighted, please do let me know, because Twitch these days they also copyright music as well. So yeah. So bear with me, guys, for this one. All right. It's 2 p.m. SGT now, so I gotta start studying, guys. Wait, are you working, Asakura? Are you not? Just start singing? Nah, I don't sing. Alright. Okay, I'm just gonna start my stuff now, because I need to make some progress on this. Been procrastinating too much lately. So, okay, for those of you who, I don't know, for whatever reason you just want to know what it is, I'm basically learning on networking stuff. But the thing about networking is that a lot of the hardware stuff is very expensive, like those really branded ones, like for example Cisco stuff. The hardware is really expensive, so I'm using simulator and I'm watching YouTube for the tutorial. So yeah. All right. I'm going to play the tutorial on another screen, which you guys are not going to see, but you guys will hear what it is. So just treat that as the music. All right.
From source to destination. So there are 3 main questions here: 1, 2, and 3. You are asked to identify the source and destination MAC addresses used as a packet travels between different points in the network. Let's get right on it with question 1. Question 1 says PC1 pings PC4. Okay, PC1 is here in the 192.168.1.0/24 network, and PC4 pings PC4. Okay, PC1 is here in the 192.168.1.0/ travels between different points in the network. Let's get right on it with question 1. Question 1 says PC1 pings PC4. Okay, PC1 is here in the 192.168.1.0/24 network, and PC4 is in the 192.168.3.0/24 network. We are asked to identify the source and destination MAC addresses at each specified point in the route to PC4. Just an aside, remember that the source and destination IP addresses will never change. The source will be PC1's IP address of 192.168.1.1, and the destination will be PC4's IP address of 192.
Yo, I'm drinking this thing. Probably I should cover the brand. It's like a soy milk drink thingy, but it tastes a little bit funny, like a bit sourish.
192.168.3.1. We are told to identify the MAC address by identifying the device and interface. To avoid clutter, I didn't write out all of the MAC addresses for each device and interface, so we'll just say R1G00, for example, instead of the whole MAC address. I'll then show you the CLI commands to verify the MAC address to check your answers. Okay, so part A of question 1 asks the source and destination MAC addresses at the connection, or the segment, between PC1 and switch 1. Well, let's think about this. Because PC4 is located on a different network, PC1 will encapsulate the packet with an Ethernet header, and the destination MAC address will be the MAC address of its default gateway. In this case, that is R1's G00 interface. So that will be the destination MAC address. How about the source? Well, that will be PC1's MAC address, since it just sent the frame. How about B, the source and destination MAC at the switch 1 to R1 segment? Well, it should be the same as in A. Switch 1 won't actually change the source and destination MAC addresses in the frame. It will simply use
I don't think that's how streaming works. You don't just add people on Discord and then you get notified. No, it's you having to follow me or subscribe to me. Rat. Whatever. I'm not gonna pronounce that. Thank you for being here, Kevin. Thank you. What the... Oof. No, why did it keep on getting deleted? Oh, this is stupid. Alright. Okay. So it's okay. I swear this thing is so janky, guys. Okay, so it looks better now.
Use the source MAC address field in the Ethernet header to learn PC1's MAC address if it doesn't already.
The robot.
No, wait. And then forward the frame to the proper. Question 1 says PC1 pings PC4. Okay, PC1 is here in the 192.168.1.0/24 network. And PC4 is in the 192.168.3.0/24 network. We are asked to identify the source and destination MAC addresses at each specified point in the route to PC4. Just an aside, remember that the source and destination IP addresses will never change. The source will be PC1's IP address of 192.168.1.1, and the destination will be PC4's IP address of 192.168.3.1. We are told to identify the MAC address by identifying the device and interface. To avoid clutter, I didn't write out all of the MAC addresses for each device and interface, so we'll just say R1G00, for example, instead of the whole MAC address. I'll then show you the CLI commands to verify the MAC address to check your answers. Okay, so part A of question 1 asks the source and destination MAC addresses at the connection, or the segment, between PC1 and switch 1. Well, let's think about this. Because PC4 is located on a different network, PC1 will encapsulate the packet with an Ethernet header, and the destination MAC address will be the MAC address of its default gateway. In this case, that is R1's G00 interface. So that will be the destination MAC address. How about the source? Well, that will be PC1's MAC address, since it just sent the frame. How about B, the source and destination MAC at the switch 1 to R1 segment? Well, it should be the same as in A. Switch 1 won't actually change the source and destination MAC addresses in the frame. It will simply use the source MAC address field in the Ethernet header to learn PC1's MAC address if it doesn't already know it, and then forward the frame to the proper destination, or flood it if it hasn't learned the destination MAC address yet. So, let's confirm these first two answers using the CLI and Packet Tracer's simulation mode. First, though, I'll send a ping from PC1 to PC4 just to allow the ARP and MAC learning processes to complete, so we can just view the ping packets in simulation mode. I'll hop on PC1. So enter the CLI of PC1, and let's ping PC4. Ping 192.168.3.1. You'll notice that when you first issue the ping command, not all of them are successful. This is because all of these devices have to finish their ARP process, and the pings time out while that is happening. Also note that in a Windows PC, when you use the ping command, by default 4 pings are actually sent. Now let's send another ping. Hit the up arrow to repeat the command, enter it, and there you go. All pings are now successful. Now let's also check the MAC addresses of PC1 and R1's G00 interface first. On a Windows PC, use this command, ipconfig/all. Scroll up here for the Fast Ethernet 0 interface, and check the physical address here, which is the MAC address. Okay, let's just remember these last 4 digits. So PC1 is 1111. How about R1? Let's check. I'll hop on R1. Enter privileged exec mode with enable, and you can view the MAC address of the interface with this command, show interface G00. Scroll up here, and it says hardware is gigabit Ethernet, address is 0000.01AA.AAAA. Again, let's remember those last 4 digits. So R1's G00 interface is AAAA. However, let me point out one more thing. Next to this MAC address, it says BIA, followed by a different address. I said in one of my lecture videos that BIA, or burnt-in address, is another word for MAC address. So what's up? Does this interface have 2 different MAC addresses? Well, the burned-in address is the actual MAC address assigned to the interface by the device maker, in this case Cisco, when it was made. However, you can actually configure a different MAC address in the CLI, and it will use that one. That's what I did in this case, to make it easier to remember. Let's check out that command to configure the MAC address. Show running config. Scroll down to gigabit Ethernet 00, and there it is. MAC-address, followed by the MAC address you want to configure. Okay, so the last 4 digits of PC1's MAC address are 1111, and for R1, they're AAAA. Now let's actually configure MAC-address, configure a different MAC address in the CLI, and it will use that one. That's what I did in this case, to make it easier to remember. Let's check out that command when it was made. However, you can actually configure a different MAC address in the CLI, and it will use that one. That's what I did in this case, to make it easier to remember. Let's check out that command to configure the MAC address. Show running config. Scroll down to gigabit Ethernet 00, and there it is. MAC-address, followed by the MAC address you want to configure. Okay, so the last 4 digits, and there it is. Show running the MAC address. Easier to remember. Show running config. Scroll down to gigabit Ethernet 00, and there it is. MAC-address, followed by the MAC address you want to configure. Okay, so the last 4 digits of PC1's MAC address are 1111, and for R1 they're AAAA. Now let's actually confirm by using simulation mode. Click on simulation mode in the bottom right here, then let's go to PC1 again, and send that ping once more. Ping 192.168.3.1. Here's the ICMP packet, and I'll hit this arrow once, so it is sent to switch 1. Let's check the source and destination by clicking here to analyze it. Look at the in layers. This is the frame as it is received by switch 1. Layer 2, Ethernet header is from 1111, which is PC1, to AAAA, which is R1's G00 interface, just like we said. Notice the layer 1 info here too, showing the physical interface it was received on. Now on the right here, out layers, is the frame as it is sent from switch 1 to R1. Notice the layer 2 info is the same, from 1111 to AAAA. This time you can see gigabit Ethernet 01 in the layer 1 info here, as it will exit out of the G01 interface en route to R1. So that's A and B. I'll close this here, and I'll just press this once more so it is sent to R1. Now let's move on to C. What are the source and destination MAC addresses at the R1 to R2 segment? Info is the same, from 1111 to AAAA. This time you can see gigabit Ethernet 01 in the layer 1 info here, as it will exit out of the G01 interface en route to R1. So that's A and B. I'll close this here, and I'll just press this once more so it is sent to R1. Now let's move on to C. What are the source and destination MAC addresses at the R1 to R2 segment? Although the source and destination IP addresses will remain the same, as R1 encapsulates the packet with an Ethernet header, it will use the MAC address of its G01 interface as the source, and the MAC address of R2's G00 interface, which is the next hop in the route, as the destination. Let's check their MAC addresses to be sure. I'll hop on R1 once more. Interface, which is the next as the source, and the MAC address of R2's G00 interface, which is the next hop in the route, as the destination. Let's check their MAC addresses to be sure. I'll hop on R1 once more. Show interface G01. Okay, the last 4 digits are BBBB. Now let's check on R2. Enter privileged exec mode with enable. Next, show interface G00. Okay, the last 4 digits are CCCC. So the source should be BBBB and the destination CCCC. Let's check. The packet is here at R1 now. I'll click on it. Now let's check the right side, the out layers, which is the packet as it is forwarded out of R1's G01 interface. You can see the source MAC of BBBB and the destination MAC of CCCC. Perfect. Okay, I'll exit out of here and click this arrow once more to send the packet to R2. Okay, now here the explanation is similar to the last step, so let's just skim through it. The source should be the MAC address of R2's G01 interface, and the destination should be the MAC address of R3's G00 interface. Let's go back to the CLI of R2 to check the MAC address. Show interface G01. Okay, the last 4 digits are DDDD. Now let's go to the CLI of R3. Enter privileged exec mode with enable. Next, show interface G00. The last 4 digits are EEEE. Okay, let's check our answer. Click on the frame here, and again let's look at the out layers. You can see the source of DDDD and destination of EEEE, just like we predicted. I'll exit this frame here, and then click the arrow again to send it to R3. Next, how about E, the source and destination MAC between R3 and switch 2? Well, at this point, the destination IP address is part of a network connected to R3, 192.168.3.0/24, so R3 knows it can send the packet directly to PC4. So, it will set the destination MAC address to PC4's MAC address, and use its own address as the source. So actually, the answers should be the same for part E and F of this question. So I'll send the packet forward once more, so we can check the in and out sections at switch 2. Okay, let's check the MAC addresses first. I'll go back to the CLI of R3. Let's check G01's MAC address. Show interface G01. Okay, the last 4 digits are FFFF. How about PC4? Let's click on PC4, click on desktop, then command prompt, and do you remember the command? It's ipconfig/all. Scroll up to the FastEthernet 0 interface, and here's the physical address, the MAC address. The last 4 digits are 4444. Okay, so for both E and F, the source should be the MAC address ending with FFFF, and the destination should be the MAC address ending with 4444. Let's click on that packet here. And notice that in both the in layers, which is the frame as it is received on G01, and the out layer. Okay, so for both E and F, The source should be the MAC address ending with F. Digits are 44. Scroll up to the Fast Ethernet 0 interface, and here's the physical. The last. Okay, so for ending with, and notice that in both the FFFF. Let's click on that packet here. And notice that in both the in layers, which is the frame as it is received on G01, and the out layers, the frame as it is forwarded to PC4, the source MAC ends with FFFF, and the destination MAC ends with 4444. So we were correct. So that's all for question 1. I'll exit simulation mode for now. Question 2 is shorter, involving a ping from PC1 to PC3. Which is on the same network. The big difference here is that, since the destination is on the same network as the source, PC1 won't send the packet to its default gateway. It will send it directly to the destination, PC3. Also, although switch 1 is in the middle, remember it won't change the source or destination MAC addresses itself. It will simply forward the frame to its destination. So both A and B should have the same answer. The source should be PC1's MAC address, which if you remember is 1111, and the destination should be PC3's MAC address. Let's quickly check PC3's MAC address. I'll go on the CLI of PC3, and now let's use that command once more. Remember, this is a command for Windows PCs. ipconfig/all. Scroll up to the Fast Ethernet 0 interface, and here's the MAC address. The last 4 digits are 3333. Okay, now before checking, I'll ping from PC1 to PC3 just in case, to let the ARP and Mac learning processes complete. Ping 192.168.1.3. Okay, now let's go into simulation mode and ping once more. Click on simulation mode in the bottom right, return to PC1, and let's ping. Ping 192.168.1.3. I'll click the arrow once to forward the packet to switch 1. Now let's check it. As you can see, as the packet comes into switch 1 via F01, and as it exits via F03, the source MAC is PC1's, ending with 1111, and the destination MAC is PC3's, ending with 3333. Okay, that's all for question 2. Now, as for question 3, I want you to post your answers in the comment section of this video. I will leave a pinned comment down below with the questions, but it will be in the same format as for question 1, but in reverse order. Leave your answers by identifying the device and interface. For example, the MAC address of R1's G01 interface. You don't need to enter the actual MAC addresses of the interfaces. Okay, looking forward to your answers. That's all for this lab. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher. Welcome to
Hold on, guys. Seems like something's on the door. So I'm gonna open the door real quick. Be right back. Alright, we're back. Someone was at the door, so back to business. Was it food for you? Unfortunately, no, it's not food for you. Have you guys not eaten your lunch? Please go ahead if you haven't. Bro, is this something stupid on the internet I think you will enjoy? What is it? Something stupid on the internet. Alright, so what happened here is that the PC1 would like to send a packet to PC3, and then the header would need to have both addresses, which is the IP address and the MAC address. So the IP address they know because the layer 3 knows, but before it sends to layer 2 it would need to have it will need to state the MAC address as well other than the IP address. So that's when the layer 3 will look up the MAC address inside the ARP table, and in this case it found it, and then it states the MAC address there and then pass it on to the layer 2. Encapsulate the PDU into the internet frame so that the layer 2 can process it, and then the layer 2 be like looking through the MAC address, it has it, so we just pass along. Okay, so it goes through the layer 1, and then the layer 2 will process it and be like, oh, this is the correct MAC address, and then it will let the layer 3 to process it, and then layer 3 be like, this is the correct IP address, so it's addressed to us. And then the packet be like, oh, it's addressed to us, and then it will check the packet, and then the content of the packet be like, oh, it's just a ping, which is ICMP in this case, and then you'll be like, oh, PC1 basically requested a ping message, which is called the ICMP echo request, and then the PC3 will start to prepare for the reply. So in this case, it will be the ICMP echo reply. ICMP process replies to the echo request by setting ICMP type echo reply. Yeah, ICMP echo reply. Process sends an echo reply to the ping in response to the ping, and then destination IP address is in the same subnet. Device sends next home destination. Then you look at the ARP table. They have it. It is and then the switch receives it and be like, oh, the MAC is found in the MAC table. So wait, what was I thinking? Okay, so MAC address, MAC table is only found in a switch. ARP table is found in other devices other than the switch. So ARP is used for PC and router. Am I right to say that? Only MAC address table is used in switch. Can watch when you're on break. I will whisper it to you. Oh, okay. I received it. What is this? It's not a video, right? Oh, it is a video. Oh my god, okay. Can I show it on stream or not? Unhindered Studios. Wait, hold on. We're in the middle of the thing. Okay, wait, so ARP table is used by Alright, okay, so we were right. I made in my explanation earlier there was a bit of what do you call it, a bit off in my explanation earlier, because if you can see over here how the internet, so basically the internet packet is first created, right, with a ping ICMP echo reply or ping reply to back to PC1, and it has to state the addresses like I said earlier. So it needs an IP address and MAC address. IP address is your internet addresses, and MAC address is basically the physical hardware address. And for devices, basically for devices other than the switch, you'll use the ARP table, but the switch will use its own table called the MAC address table to check for the MAC address. So for back to PC3 over here, the IP, you set the IP source and destination, which is pretty simple. The source is itself, the destination is PC1, but it needs a way to state the MAC address of the PC1. So you yeah, this is a request, and then you set the destination IP address, and then the layer 2 you have to set the MAC address. So you use the up process, which will check on the up table whether it has the record, the MAC address IP address mapping record, and in this case it has. So then it will state the MAC address on the destination, on the destination MAC address, and after that it will package everything into the as a Ethernet frame, so that it can be sent out through the internet connection. But on the switch it's different, right? Because switch is always like just a layer 2. So what happens, that switch is just passing data along. So once it receives the frame through the Ethernet cable, it'll unpack it, it will take a look at the MAC address, and it has to check what's the destination MAC address, and then it will cross-check with its own MAC address table, the record basically, and in this case it's there, so it just passed along through the port. So what happens is that for the switch, it's more of like a port MAC address mapping as compared to the ARP table, which is more of like IP address MAC address mapping. Okay, MAC address found in the MAC table. Yeah, switch looks at the MAC table destination, found it. It's a export, then send the frames out from that port, which is fast Ethernet 1 in this case. Okay. And then the PC1 receives it, and then you'll check the frame's destination MAC address is itself, and then you'll decapsulate it, and then you'll check the destination IP address, the packet's destination IP address, you'll unpack it, the packet's destination IP address basically itself as well. So you start to unpack the content of it, the data content, and it turns out that it's an ICMP packet, or known as the ping data basically. So the ICMP process will process it, and then when it processing it, oh, there's a truck. I was like, why is there such random sound? Okay, so when the ICMP process is processing it, it turns out to be the echo reply message, which is known as the ICMP echo reply or the ping reply, and that's it. Then it ends there. Cool. You guess so? Alright. I'm gonna open it later. So basically, I can say that only the switch will use the MAC address table, but the other devices will use the up table to check for MAC addresses. Okay. Alright, so let's do this last one. Too lazy to comment on his video, so I'm just using this as the platform for me to, for some reason, if one day someone found this video and can help me to correct it. Alright, so we're supposed to send PC4 to PC1, right? Wait, hold on, let me end this thing. Okay, we are supposed to send a ping from PC4 to PC1. So what are the MAC addresses, right? When it's over here, the source MAC address would be the PC4 MAC address. The destination will be the router 3 MAC address. When you reach the switch 2, the source MAC address is still the PC4 MAC address, while the destination is router 3 MAC address. The reason is because the functionality of a switch is just forwarding the data, forwarding the frame. And then when it reaches router 3, the source MAC address is still the incoming, yes. So when it reaches router 3, it's going to go router 2 next. So the source MAC address is changed to router 3. The destination MAC address is router 2, so that it can pass the frame along to the next hop. And then when it reaches router 2, the source becomes router 2's MAC address, destination will become router 1's MAC address. When it reaches router 1, the source will be the router 1's MAC address, destination will be the PC1 MAC address instead of switch 1, because switch doesn't really have, basically what switch does is just forwarding. And then when you reach switch 1, the source is still the router 1's, but the destination MAC address is PC1's. And then it will pass along, and PC1 will be like, oh, okay, the frame's destination MAC address is mine, so I'm going to unpack it. After I unpack it, there's another address label. Oh my god. Sorry guys, there's a jet flying low, so I gotta mute there. Otherwise it's a bit loud. Where was I? Oh yeah, it was unpacking, and then there's another label, IP address label. So there's a IP address label, and then the destination IP address is his PC1's IP address. Then it will be like, oh, that's me as well. So I'm going to unpack it, look at what's the content inside. Turns out it's labeled as ICMP, so it lets the ICMP feature to process it. And when it's processing, the data is the ICMP echo reply, or basically is the ping reply to the initial ping request by PC1. And when it's from PC1, it's using up table to check for the MAC address. When it's on the switch, it uses MAC address table to check for the MAC address. When it's at the routers, they use the up table to check for the MAC address. Okay, cool.
to Jeremy's IT Lab. This is a free, complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, remember to download subnetting using VLSM, Variable Length Subnet Masks. This will be very similar to the end of Day 15's lecture video. You will subnet a Class C network into 5 subnets of different sizes. So I highly recommend that you try to complete this lab first, before watching this video to check your answers. We are required to subnet the 192.168.5.0/24 network to provide sufficient addressing for each LAN.
Hold on guys, let me look for a pen.
as well as the point-to-point connection between R1 and R2. We will follow the same process that I introduced in Day 15's lecture video. Assign the largest subnet at the start of the address space, and then the second largest, etc., until you have assigned each subnet. So that means we will assign subnets in this order: LAN 2, LAN 1, LAN 3, LAN 4, and finally the point-to-point link. The instructions also say to assign the first usable address to the PC in each LAN, and the last usable address to the router. Finally, we should configure static routes so that hosts in each LAN can reach hosts in the other LANs. So let's get started with LAN 2. I hope you've already solved this lab and are just watching this video to check, since I won't go step by step through each calculation like in the lecture video. Let me tab out to this document where I've calculated all of the answers. So for LAN 2, we must use a /25 prefix length. LAN 2 only requires 64 hosts, and as I've written below, a /25 prefix length allows for 126. But if we used a /26 prefix length, there would only be enough addresses for 62 hosts, because we have to subtract 2 for the network and broadcast addresses. So LAN 2's network address is 192.168.5.0, and its broadcast address is 192.168.5.127, both /25. Let's assign the addresses to PC2 and R1. Let me go on R1 first. First, enter privileged exec mode with enable, then enter global config mode with configure terminal. R1's gigabit Ethernet 01 interface is in LAN 2, so interface G01 to configure it. The broadcast address is 192.168.5.127, so let's configure R1's IP address as one below it, the last usable address. IP address 192.168.5.126 And for /25 prefix length, the subnet mask will be 255.255.255.128. Also, let's enable the interface with no shutdown. Let's confirm our configuration. Do show IP interface G01. The show IP interface command shows various information about the interface, primarily layer 3 information. You can see here that the IP address has been configured correctly. You may notice the broadcast address of 255.255.255.255. This address basically functions the same as the subnet broadcast address of 192.168.5.127, and it can be used for any network. When we configure other IP addresses and use this show IP interface command, those other interfaces will display the same broadcast address too. Keep in mind, if a host sends a broadcast to 255.255.255.255, it won't be sent to all networks. It will still stay in the local subnet, and a router will not route it to other networks. The subnet broadcast address, however, 192.168.5.127 in this case. Welcome to Jeremy's IT Lab. This is a free address written below a /25 prefix 2 you must like in the lecture video. Let me tab out to this document where I've calculated all of the answers. So for LAN 2, we must use a /25 prefix length. LAN 2 only requires 64 hosts, and as I've written below, a /25 prefix length allows for 126. But if we used a /26 prefix length, there would only be enough addresses for 62 hosts, because we have to subtract 2 for the network and broadcast addresses. So LAN 2's network address is 192.168.5.0, and its broadcast address is 192.168.5.127, both /25. Let's assign the addresses to PC2 and R1. Let me go on R1 first. First, enter privileged exec mode with enable, then enter global config mode with configure terminal. R1's gigabit Ethernet 01 interface is in LAN 2, so interface G01 to configure it. The broadcast address is 192.168.5.127, so let's configure R1's IP address as one below it, the last usable address. IP address 192.168.5.126, and for a /25 prefix length, the subnet mask will be 255.255.255.128. Also, let's enable the interface with no shutdown. Let's confirm our configuration. Do show IP interface G01. The show IP interface command shows various information about the interface, primarily layer 3 information. You can see here that the IP address has been configured correctly. You may notice the broadcast address of 255.255.255.255. This address basically functions the same as the subnet broadcast address of 192.168.5.127, and it can be used for any network. When we configure other IP addresses and use this show IP interface command, those other interfaces will display the same broadcast address too. Keep in mind, if a host sends a broadcast to 255.255.255.255, it won't be sent to all networks. It will still stay in the local subnet, and a router will not route it to other networks. The subnet broadcast address, however, 192.168.5.127 in this case, can be used by hosts in other subnets to send a broadcast to this subnet. Anyway, I think I'll explain that in a lecture video in the future, so don't worry about it. I just wanted to explain it since you can see it here. Okay, now let's configure PC2. Click on Config, then first set the default gateway to R1, 192.168.5.126. Then click on Fast Ethernet 0, and set the IP address and subnet mask. The first usable address is 192.168.5.1. After you enter it, you can press Tab, and notice it tries to fill in the subnet mask for me. However, since this isn't a classful network, it's a subnet, let me change the last octet to 128. Okay, that's all for this subnet. The second largest subnet is LAN 1. Let me go back to my document and let's look at LAN 1. So for LAN 1, we'll use a /26 subnet mask. LAN 1 requires 45 hosts, and a /26 subnet mask allows 62. The network address is the next address after LAN 2's broadcast address, so it's 192.168.5.128/26. The broadcast address, with all host bits set to 1, is 192.168.5.191. Let's configure the router and the PC. I'll go back to R1 first. Let's configure the G00 interface with the last usable address. Interface G00. IP address 192.168.5.190, 255.255.255.192, which is the subnet mask for /26 prefix length. Enable the interface with no shutdown, and let's check. Do show IP interface G00. The IP address is correct, and you can see the same broadcast address, 255.255.255.255. Next, let's configure PC1. Click on Config, set the gateway to 192.168.5.190, then click on Fast Ethernet 0, set the IP address to 192.168.5.129, hit Tab, and then change the last octet to 192 for the /26.5.128. Since this isn't a classful 128, and let's configure by host broadcast network base command 255.255.128. Also, let's enable the interface with no shutdown. Let's confirm our configuration. Do show IP interface G01. The show IP interface command shows various information about the interface, primarily layer 3 information. you can see here that the IP address has been configured correctly. You may notice the broadcast address of 255.255.255.255. This address basically functions the same as the subnet broadcast address of 192.168.5.127, and it can be used for any network. When we configure other IP addresses and use this show IP interface command, those other interfaces will display the same broadcast address too. Keep in mind, if a host sends a broadcast to 255.255.255.255, it won't be sent to all networks. It will still stay in the local subnet, and a router will not route it to other networks. The subnet broadcast address, however, 192.168.5.127 in this case, can be used by hosts in other subnets to send a broadcast to this subnet. Anyway, I think I'll explain that in a lecture video in the future, so don't worry about it. I just wanted to explain it since you can see it here. Okay, now let's configure broadcast address. So it's 192.168.5.192/28. The broadcast address is 192.168.5.207. Let's go configure R2. Enable conf-t interface G00. Let's configure the last usable address here. IP address 192.168.5.206, 255.255.255.240, which is the subnet mask for a /28 network. Enable the interface with no shutdown, and let's confirm. Do show IP interface G00. So the IP address is correct. Next, let's configure PC3. Click on Config, set the gateway address to 192.168.5.206. Click on Fast Ethernet 0, IP address of 192.168.5.193. Hit Tab, and then change the last octet here to 240. Okay, that's all for LAN 3. Next is LAN 4. Let's go back to that document. So for LAN 4, we will actually use a /28 also. LAN 4 requires only 9 hosts, so a /29 prefix length, which allows only 6 hosts, would be too small. The network address is 192.168.5.208, and broadcast address is 192.168.5.223. Now let's go back to R2 and configure its G01 interface. Interface G01. IP address 192.168.5.222, 255.255.255.240. Enable the interface with no shutdown. And let's check. Do show IP interface G01. Okay, the IP address looks correct. Let's go to PC4. Config, set the gateway to R2's address, 192.168.5.222. Fast Ethernet 0, set the IP address to the first usable address, 192.168.5.209. Hit Tab, and change the last octet of the subnet mask to 240. That's all for LAN 4. The last subnet we have to assign is the point-to-point connection between R1 and R2. Let's go back to the document. So we can use a /30 or /31. I'm going to go with /30. I just think it's the safe option to go with on a Cisco test. So the network address is 192.168.5.224, and broadcast address is 192.168.5.227. We'll use the first usable address for R1 and last usable address for R2. In fact, those are the only 2 usable addresses. Let's go on R1. Interface G000. IP address 192.168.5.225, 255.255.255.252. Enable the interface with no shutdown. Let's check it. Do show IP interface G000. Okay, the address looks good. Now let's go on R2. Interface G000. IP address 192.168.5.226, 255.255.255.252. And enable it with no shutdown. And finally, let's confirm. Do show IP interface G000. Okay, no problems here. Now the last step is to configure static routes on each router. Each router has 3 connected networks. Those are the point-to-point link, and LAN 1 and LAN 2 for R1, or LAN 3 and LAN 4 for R2. So we'll have to configure 2 static routes for each router. First, let's configure the routes to LAN 1 and LAN 2 here on R2. Exit to go back to global config mode. First, LAN 1. IP route, then LAN 1's network address, 192.168.5.128, 255.255.255.192. Then let me use the question mark here. Note that you can either specify the exit interface of this router or the IP address of the next hop. I'll go with the next hop, 192.168.5.225. Okay, that's it. Next to LAN 2, same thing. IP route 192.168.5.0, 255.255.255.128, and then the next hop of 192.168.5.225. Let's check the route table. Do show IP route. Okay, you can see the connected and local routes here, and then the 2 static routes we just configured. Let's go on R1 and configure the routes to LAN 3 and LAN 4. First, exit to return to global config mode. So the route to LAN 3 first. IP route 192.168.5.192, 255.255.255.240, then the next hop of 192.168.5.226. Okay, now to LAN 4. IP route 192.168.5.208, 255.255.255.240, 192.168.5.226. Let's check the route table. Do show IP route. Okay, looks like R1 has all of the routes it should. Let's just try a ping from PC1 to another PC. Let's try PC4 to make sure our routes work. Really, you should try to ping all other PCs, but I'll show just one. Okay, so from PC1 CLI, let's ping to PC4. Ping 192.168.5.209. Now, because the ARP process hasn't completed yet, there may be a few failures, but if I keep talking, you should see that PC1 can now reach PC4. Okay, so we have successfully subnetted and configured a network, and then configured static routes to provide reachability. That's all for this lab. Thank you for watching. This is a free
So what I'm doing here is just, after configuring everything, I'm just trying to do a ping check on every single PC. It seems like it's working. So I'm using PC1 trying to ping for everything else. So I just assume that once the ping goes through, then that means that everything else will work as well. But if you notice earlier, pinging from PC1 to PC2 is a lot faster because it just goes this way, it doesn't go out. So I think that's why it's a lot faster. Meanwhile, when it goes to these two, I think there was a bit of loss, right? 193 and 209. Yeah, 193 there was a timeout. So basically, it was doing an up process, whereby it's trying to find out the MAC address before it actually sends out the ping. Because subsequently, as you can see over here, it goes through smoothly, the ping. And then for PC4, the same thing happened, except there's only one request timeout, but still there's a timeout. But for the next three pings, ping packet that is sent, it was successful. And that said, if let's say we try one more time, it should go through, all four packets will go through successfully without any loss. Yeah, so receive 4, lost 0. Okay, so we are pretty much done, but I want to do a little bit of, done with this lab, but I want to do a little bit of practice with the switch. So let's see, we can start with configuring the switch name to switch 1, and then let's check the interfaces. Okay, yeah, so we can see that this one is connected, this one is for the PC, and then this one was previously down. This is the connection to the router, but now it says it's connected, so it's good. So that way we can just move on to doing a little bit of aesthetic configuration, starting with the description. And then no shutdown, even though it's already connected, it's already up, but we just do no shutdown so that we know that it will continue to go up. And then next will be the gigabit internet. This one is for the router. No shutdown. And then next we do the interface range for fast Ethernet 2 up to 24 with the gigabit Ethernet 2. So this one we want to shut down. We'll put a description, not used, then we put shutdown to shut the whole thing down. Then we show the interfaces status again. So yeah, so you can see here fast Ethernet 1 is connected to the PC1 is connected. So it's cool. But from port 2 till port 24 we disable it because it's not used. This one, gigabit Ethernet 1, is the connection to router 1, it's connected, but gigabit Ethernet 2 is not used, so we disable it. Okay, perfect. I think that's all we need to do for this switch. Then we just need to do for the next 3. Alright, yeah, we are configuring this one halfway. Just interface status. T. Then we show the interfaces. Alright, and if this one is to PC4, so to router 2, shut down, then we do a range to port 24, and then the gigabit Ethernet port 2. Not used, and then we shut down the ports, the unused ports. So we show the interfaces status again. It would be two ports connected, the rest not connected. Okay, this is good. Oh wait, we forgot to change the host name. Okay, we changed the name from switch to switch 4. Alright, just do a double check real quick. Host name switch 4, description shutdown to router 2, now shutdown. Okay, alright, perfect. Then we just do a final check again before we call it done. So again, ping 192.168. This one is from LAN 1, so we want to connect to ping LAN 2, LAN 3, LAN 4. So let's start with LAN 2. Oh my god, that scared me a little bit. I thought we did something wrong. Alright, perfect. And next we ping PC3. Good. Ping sys4, ping PC4. Alright, nice. We're done with this lab. What lab is next? Lab 16. Alright, this is lab 15. VLSM. VLSM is what? Variable length. Variable length. What's VLSM? Variable length. Subnet mask. Oh, variable length subnet mask. Okay. Alright. Cool. Let me check real quick. 15. Or 16. V16 is VLAN. Oh my. Okay, let's take a quick break. How many did we do today? I mean, so far, not today, but so far. 1, 2, 3, 4, 5. We did 12, 15. Life of a packet and variable length subnet mask. Okay, so it's 2. All right, let's watch the Reddit thing that is sent by Asakura. Quite curious. You guys see this? Oh yeah, nice. Okay, this is quite curious. So with this one, Ah no, this.
To do is run right at that wall and you'll end up where you need to be.
Okay, I think it's better if I just show the whole thing. This is not the real thing. Is it? It's not the real thing, right? This couldn't be the real thing. Yeah, there's a source from this TikTok. Top here. Oh man, comments like it. Comments like it. This is kind of like Codex Cloud Code. Whatever. Yeah, let's watch this one again.
Well, Harry Potter, this is where you go off on your own.
Where do I go, Broski? This is just a normal train station.
You'll need to find platform 6, 7, then take the Maybach Express to
Broski!
All you gotta do is run right at that wall and you'll end up where you need to be.
Type shit? Say on guard!
On guard! Fall into trick walks.
Wait, what?
Come on now. All you gotta do is run right at that wall and you'll end up where you need to be.
Type shit? Say on guard!
On guard!
Oh my god, I just realized. Wait, let me try to
You'll
pause
need
it.
to find
It's branded?
platform 6, 7, then take the Maybach Express to Trick Walks. Come on.
Swagrid. 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 Oh my god, look at this Rolex, man.
Come on now. All you gotta do.
Oh, this actor looks so similar to the real Hagrid. The Harry Potter is different though, but we know that already. Look at this, another branded stuff. The owl is freaking branded, guys. This is the owl, right? It's freaking branded.
Do is run right at that wall and you'll end up where you need
Wait, oh my god, I just missed it again. Can you imagine the plaque itself is branded?
and you'll end up where you need to be.
Type shit? Say on guard!
On guard!
Trying to go through the magic wall!
He wasn't. That was just a crackhead trying to steal your shit, okay?
Huh?
So what now?
Dobby is coming. He will get you there faster.
Oh hell no. There will never be a car on a freaking wait. But it's a car. It's the car. Dobby Sock Boss.
Ron! That's Harry Potter. Are you really Harry Potter, my
His teeth. Oh man, this is the pig, bro. I mean, he still looks like, you know, Wesley, right? But his teeth.
Gee.
Type shit.
Type shit.
Oh my god, Hermione.
None of that, broski. We're all here on the Maybach Express for one reason and one reason only.
Maybach Express. Zero parents. Oh my god.
And that's to go to Dripwatch, the school of drip.
What the heck? Yeah, this AI video, alright. You guys know it. You guys see it firsthand. This is just for fun. This is just for laugh. Disclaimer. Oh my god. I'm not sure whether there will be copyrighted, so I'm just gonna mute the song a little bit.
Let me check this out. Harry Potter! They say you are the boy who tripped.
Is this the current actor? It's pretty good though. It kind of looks alike.
Are you not, Broski?
Oh my god, the Hermione!
What a loser.
For your sakes, I hope the three of you are ready, as today is house sorting day. Snape will explain further. He's just moved here.
Oh my god, the Snape is wearing... Wait, is that real? Like, is that... Oh my god, I hope it doesn't work that way. I mean, he's wearing a freaking tight jeans.
There are 4 main houses.
Oh, it's so...
Dripping.
We own this bitch, you're here?
And Dripping Pub.
Morning, Myrtle be morning tonight.
Where's the sorting hat? Dobby is on his way with it.
Wait, the sorting hat is delivered by Dobby? Who are the 2 ladies though? Oh my god. Oh, I can't. But the details though, the attention to details. Like the branded stuff, the owl was branded, and then the necklace with all the writings. Oh well. Well, that was a good ending, huh? Alright. Okay, this live stream is not supposed to be long, so I'm going to end it here. Thank you so much again for all of you for being here. For those of you being here for some reason, for you guys like who like to watch me type stuff, rambling stuff. Thank you so much for being here again. I know this is the first live stream for the tech channel, but it's not the first live stream for my Twitch channel, because for Twitch channel, oops, there's a thunder, it's gonna rain. Alright, so for the Twitch channel, guys, there's going to be only one Twitch channel, so everything, whenever I'm going to go live stream, is going to go to this channel. Alright, but on the YouTube side, it's a new YouTube tech channel. Okay, yeah, I haven't put it inside my Twitch bio, but you can see it here. This is the YouTube handle, guys. So if you guys are curious about my tech channel, you can go to this YouTube channel called deddycation. You can just attend there. Alright, otherwise if you prefer on Twitch channel, well, you don't need to move, because this is the only Twitch channel that I'm going to stream on. Alright, so other than that, thank you so much again. That ending though, that was good. that video, oh my god, it was AI video, but it was good. Thanks again, Asakura, for being here. Honestly, I didn't expect anybody to turn up, really. I mean, it's daytime, but well, thank you so much again for being here. With that, I'm going to see you guys on the next one. You know, stay tuned, you don't want to miss it. Do consider follow and subscribe, guys. Alright, see you. Take care. Bye bye. Love you guys. Bye bye. Oh yeah, one more thing. There may be more of such live stream. Alright, so other than game streaming, there will be more of such tech, coding, IT streaming, hopefully. But yeah, see you guys on the next one. Alright, don't miss it. I'll see you there. I will see you there. I'll see you there. Okay, follow and subscribe. Bye bye. Don't forget. Bye bye. Thanks for watching.